I'm going to talk about how we are planning for introducing connecting autonomous vehicles in Greenwich. From a local authority perspective, our interest in connected autonomous vehicles is twofold. First, we want to understand how they can help us improve the mobility services we offer to our citizens. And two, we want to understand the urban design and urban planning implications of their introduction in our cities. We started working on connecting autonomous vehicles once we knew we had been successful with our Gateway project, which is an 8 million research project funded by Innovate UK, and it's led by the Transport Research Laboratory. The goal of the project is to understand and overcome the technical, legal, and societal challenges of introducing connecting and autonomous vehicles in our cities. The trials are taking place in the North Greenwich Peninsula, and the vehicle we're using for these trials is the one you see in the image, which can accommodate between 4 to 6 people. For these first trials, the vehicle is not sharing the road space with current vehicles. However, it's our ambition to move this autonomous shuttle from this laboratory and artificial environment to a much more real one. So in parallel to the trials, the Gateway project is also looking at other legal, insurance, cybersecurity, urban design, and urban planning related challenges. Today I will be speaking about the concepts and objectives in relation to connected and autonomous vehicles that we are exploring in Greenwich with two purposes. First, to ensure that our urban environments, the built environments, are designed to support the introduction of connected and autonomous vehicles in our cities, but also to ensure the good and smart use of the technology associated to connected and autonomous vehicles to deliver more sustainable and resilient cities. Just a very quick context of Greenwich. Greenwich is one of the 6 East London growth boroughs, so it has the responsibility to accommodate a large proportion of the capital's future growth. In the next 15 years, the population in Greenwich will increase by a third, so the borough is having to face with growing pressures on public space, pressures to deliver public services to a rapidly increasing number of citizens, and there are also growing demands from the civil society and from the business community to become an emission-free and congestion-free borough. So we are clear that with this development context, business as usual is no longer an option for Greenwich, and we have decided to adopt a holistic approach and to look at the interdependencies between the design of the built environment, the design of the vehicle, and the design of the mobility service. And these interdependencies are evidenced by the evolution of cities' urban morphology and most utilized transport systems. In the pre-industrial city, most travel was on foot. People lived close to where they work, and this resulted in compact, dense human-scale settlements. Industrialization fostered large-scale urbanization. This urban expansion was initially driven by the introduction of buses, trams, and regional railway services, which allowed faster travel and access to a wider geographical area. But further technological progress, coupled with the reduction of mobility costs relative to incomes, allowed the widespread adoption of privately owned vehicles, and cities de-densified and expanded horizontally. So throughout this journey, we've been substituting access by proximity with access by movement, and cities have moved from being dense and compact cities to sprawling cities. And this is the result in some cities around the world. And it is important to note that at 50 kilometers per hour, private cars take 40 times more space than buses, and that private cars are idle most of the time and occupy 80% of the city's land area. So if we follow this business as usual trend, the urban travel, which today constitutes approximately 60% of all kilometers traveled globally, will increase threefold by 2050. The urban areas, which they occupy approximately 3% of the planet's surface, will triple in just 30 years. And the area in city centers dedicated to parking, which today is about 80% of the city center's land area, would need to increase the equivalent of the size of Denmark. So this will lead to further dedensification, greater congestion, and higher car and parking pressures on public space. And these outcomes will be accompanied by a decrease of the productivity levels of cities due to congestion and time loss in city trips. Also, the cost of projects are more expensive in sprawling cities because the provision of infrastructure per unit is more expensive at lower levels of density. From the social perspective, cities that are highly reliant on city trips are less socially inclusive. There is a correlation between transport modes and most utilized transport systems and social class, sorry. And from an environmental point of view, even if we assume that in the future all vehicles will be electric, sprawling cities require much more space, and we need to put in place much more physical infrastructure, and this obviously has a negative impact on the planet's natural resources. And finally, there are some health implications. Increasing levels of motorization lead to a decrease of activity levels of citizens, and we in Greenwich today we are having to fight obesity, which is a key priority in the borough. Like cutting down obesity is important for Greenwich. So we are very clear that we need a paradigm shift. We need to stop thinking exclusively in terms of urban mobility and think more in terms of urban accessibility. And urban accessibility in cities can be increased by working on the urban form and urban structure of cities, through transport systems and networks, and by deploying digital infrastructure and new technologies, which can lead to a new mobility behavior and more productive, socially inclusive, and environmentally friendly cities. So how can we increase accessibility, urban accessibility, by working on the urban morphology? These are two examples of city models. The one on the left is a sprawl and segregation use city. In this city, uses are segregated spatially. So there is an area where we live, another one where we work, another one where we socialize, and different one where we do our shopping. And then when we map spatially local workers and local residents, there is no correlation. So this city is highly reliant on city trips. And the impact in the transport network is that it's rather extensive and inefficient. On the contrary, if the compact, polycentric, and mixed-use city, in this city, uses overlap spatially. So neighborhoods are designed to be able to accommodate employment, housing, for citizens to be able to socialize, do their shopping, exactly. So this city, when we overlap all these uses, we are helping citizens to meet their needs locally and to avoid having to travel in the city. And the impact on the transport network is that it's a lot more compact and efficient. So the compact, polycentric, and mixed-use city is a public and shared transport-oriented city, while the sprawl and segregation city is a private car-oriented city, which constantly requires more and more space and leads to further sprawl. So this strong relationship between the city's urban morphology and the most utilized transport system is evidenced by this slide. On the left, we see the percentage of trips in London. In yellow, we see inner London, some inner London boroughs, which are characterized by higher densities and intensity of uses, and in blue we have some outer London boroughs characterized by the opposite, lower densities and less diversity of uses. And what we see is that the number of trips made by non-motorized transport in inner London is a lot higher than in outer London. And the reason is because the urban morphology in inner London boroughs favors cycling and walking distances. We also see that the percentage of trips made using the tube is a lot higher in inner London than in outer London. And the reason is that in inner London, the transport network is a lot richer. The transport offer is richer again. And this is because of the city's urban morphology. As we said before, the provision of infrastructure is more expensive per unit at lower levels of density. So if we increase density, it facilitates investment in infrastructure. And this is in line with what we see on the picture on the right. We see that in inner London we can move at 40 to 50 kilometers flexibly in all directions. However, in outer London, even though we can reach the same speed, we are constrained directionally. So if we want to go from A to B, we have to pass by C, and then the connection between C and B is not ideal. And this is why people in outer London or in areas characterized by lower densities take their private cars, because they can reach 50 kilometers per hour and move freely and flexibly around. So this is what we want to address in Greenwich. In Greenwich, by designing the built environment much more intelligently, by implementing or incorporating connected and autonomous vehicles and embracing mobility as a service, we want to address the directional constraint we have in outer London and allow people to move flexibly in the borough. We'll see later how. So we are very clear in Greenwich that we need to move away from a chaotic and unsustainable urban morphology and embrace a much more sustainable and functionally structured city, which is the Polycentric City, based on the principles of the compact and mixed-use city. The Polycentric City, in the Polycentric City, we have different city centers with different degrees of self-sufficiency, depending on the level of densities, intensity of flows, and intensity of uses. And it works around pyramids of intensification around main transport hubs. So the transport hubs are the black dots in the image, and where there is a transport hub, we can accommodate more densities and more intensity of uses. The blue is darker, and as we move away from the transport hub, the density and intensity of uses decrease, which is these pyramids of intensification. And if we approach the design of our cities in that structured manner, we will be able to plan and design for much more efficient transport networks. So in a given polycentric city, where we have different city centers with different degrees of self-sufficiency, we will have the central city district, which is the center accommodating higher densities and intensity of uses. And then as we move down in the hierarchy, we have other city centers with lower densities and intensity of uses, neighborhoods and local areas. And we see that each of these urban centers have been assigned a transport offer. So the central city district is served by an intercity train station, by a metropolitan rail station, underground station, bus stations, and it also needs to be designed to accommodate, to be able to walk and cycle safely. And as we move down in the hierarchy to local areas, we see that the transport offer decreases. So in Greenwich, we don't see connected and autonomous vehicles competing with the current existing public transport offer we have in our cities. We don't think that connected and autonomous vehicles can beat the efficiency of the tube, but we see them as complementing the existing transport offer to increase accessibility in those areas of the city that today are less well served by public transport. So with the rapid growth of connected devices in the world, the opportunities for vehicles to harness and to take advantage of the newly available information are increasing exponentially. The use of vehicle-to-infrastructure and vehicle-to-vehicle technologies allowed connected and autonomous vehicles to gather and receive data from an increasing number of devices and sources, to process the relevant data, and based on it, make informed decisions which will be generating new data that will be then again shared with the network of connected vehicles, devices, and infrastructure. So connected and autonomous vehicles are equipped with some sensors that allow them to gather information about their immediate surroundings, like other cars, pedestrians, obstacles, potholes. They also have some comms component which allow them to receive information from areas that are not so close to where they are. They will know where there is congestion in the city, where there has been a car accident or an accident and there is some chaos, so areas to avoid. They will know where there is an event in the city, so where the demand for connected autonomous vehicles may increase in the next few hours. And then based on that, they will make informed decisions and operate accordingly. They can talk to each other with vehicle-to-vehicle technologies and also to infrastructure through vehicle-to-infrastructure technologies. And all these feedback loops, real-time feedback loops, allow them to be a lot more predictive and responsive in complex urban environments, which leads to the reduction of road accidents, to the reduction of congestion levels, and to increase on seamless mobility in our cities. However, in order to fully harness the potential of the opportunities that connecting autonomous vehicles bring along, we think it is important to accompany them with new business models and new mobility services. And in Greenwich, we're looking to reduce the private vehicular mobility and the travel intensity in the borough by embracing mobility as a service that is moving away from asset ownership and embracing service provision and utilization. And this allows us to make a much more productive use of the assets. Vehicles won't be idle most of the time. They will be constantly moving, and we will need less vehicles to meet the mobility needs of the population. So that will lead to a much more productive use of the space and management of urban spaces, because we will be able to eliminate parking usage from cities, and also all the real-time information, all these feedback loops of information allows us to match much more efficiently in real-time demand and supply, and we can develop flexible and real-time land use strategies. We can dedicate some road space to other uses when the mobility demand is not high, and give it back to mobility when the demand of the area for mobility in the area increases. And this is my last slide, which captures our framework in this strand of work. As I said at the beginning, we are looking at the interdependencies between the design of the built environment, the design of the vehicle, and the design of the mobility service. We are clear in Greenwich that we cannot overcome the mobility and transport challenges in cities by only focusing on one of these pillars. Because what we will find out is that cities are complex environments with different areas, and these different areas will have different mobility requirements that need to be associated with a different or a specific type of vehicle. Thank you very much.